Okay, let's do this. And pop up the chat so that I can read along. Advent of Code Day 2 is here. So yeah, yesterday we had a bit of fun. Struggled with the extension settings that I wrote. Let's see if today can be a bit smoother. Let me turn down my music a bit. Okay, so day 2, rock, paper, scissors. The elves began to set up camp on the beach. To decide whose tent gets to be closest to the snack storage, a giant rock, paper, scissors tournament is already in progress. Rock, paper, scissors is a game between 2 players. Each game contains many rounds, and each round the player each simultaneously choose one of rock, paper or scissors using a handshake. Then a winner for that round is selected. Rock defeats scissors, scissors defeats paper, and paper defeats rock. If both players choose the same shape, the round instead ends in a draw. Appreciative of your help yesterday, one elf gives you an encrypted strategy guide, your puzzle input. That will then, that they say will be pretty sure to help you win. The first column is what your opponent is going to play. A for rock, B for paper, C for scissors. The second column, and suddenly the elf is called away to help with someone's tent. The second column you reason must be what you should play in response. X for rock, Y for paper, and Z for scissors. Winning every time would be suspicious, so the responses must have been carefully chosen. The winner of the whole tournament is the player with the highest score. Your total score is the sum of your scores for each round. The scores for a single round is the score for the shape you selected. 1 for rock, 2 for paper, 3 for scissors, plus the score for the outcome of the round. 0 if you lost, 3 if the round was a draw, and 6 if you won. Since you can't be sure if the elf is trying to help you or trick you, you should calculate the score you would get if you were to follow the strategy guide. For example, suppose you are giving the following strategy guide, and this strategy guide predicts and recommends the following. In the first round, your opponent will choose rock, and you should choose paper. This ends in a win for you with a score of 8. The second round, your opponent will choose paper, and you should choose rock. This ends in a loss for you with a score of 1. The third score is a draw with both players choosing scissors, giving you a score of 6. In this example, if you were to follow a strategy guide, you would get a total score of 15. What would your total score be if everything goes exactly according to your strategy guide? Okay. So I assume after this we'll have to figure out each possible input. But yeah, let's code this up. Let's look at the input for now. I can do that later. Okay, so we copy day 0 and name it day 2. I should probably set up the zoom back to 150% so you can more easily read along. This becomes day 2. The base is 2. Okay. Let's see. Let's look at the input for a bit. So this is just a continuous stream of 2 characters with a space between them. Okay. Sure. Okay. So far round is input 2 lines. Okay, and then we should probably select, we should probably define the moves first. Let's see, we had A was, let me see, A for rock, B for paper, C for scissors. So we can have public enum opponent move. So we have A, B is 2, C is 3. Actually, this is rock, paper, scissors. I'm just thinking of all the data that belongs to it and what the best way is to code it up. Probably need to have a function to test what everything is. So because we have a few pieces of data, right? We have the letter mapping, name, a label, a value, beats, letter, loses, letter, draw, letter, plus the values according to that, right? So you have A beats B, loses, the rock beats C actually. So rock beats scissors, loses paper, draws the other one, draws when it's equal. And there are scores associated with those as well. So let me see. Extra. So we have those. 1, 2, 3. Okay. So for the ones that you play, we have these scores as well. And then for the outcome, it's 0, 3, 6. So we have constant lose points 0, constant draw points is 3, constant win points is 6. And we have R move, X, Y, Z, right? X rock, Z paper, Y paper, Z scissors. So these are the points that we get, these are the points that they get. That's fine. I'm just thinking how we should do a mapping. Like you can do a you could do a dictionary of char, beats, char, beats. Is that still a lookup then? Yeah, it beats int points. Maybe a nested dictionary. So this is the value that it would, let's see, points. I'm just thinking what the best way is to hook it all together, because it's a basic rule set that we have to define, and I can code it all out, but I always like to code stuff in a way that you configure the data and then just process it. So we could probably have it like this, because this would give you the absolute point value for playing that. So this would be play mapping, and then we can actually do name of let's see, it was first the R move and first the opponent move and then R move, right? Let's see. Yeah. So it's the opponent move and then R move. So it will be opponent move dot A, and then we do block. So if we have A, then we have a new set of values here. So we can do, this becomes our move dot x, and that gives a, let's see, do we do all the points at the same time? No, we just give the score outcome. That would be draw point. Why doesn't it like this? Invalid member declaration. That should be good. Ah, I didn't have name on. Okay, it's still early, sorry. I'm just thinking if there's a better way to do this than to because this is the mapping. If we have the rules set out, yeah, let me just continue because I think I will think about it too long. So we have A, B, and C. So let's see. A is rock. So let's see. So A to Z, A to X is draw. A to where I play paper, then we win, right? Paper beats rock, so this will be win points. And this will be lose points. So if you, if they play rock and we play scissors, then we lose. I'm already regretting not naming these just. Let me just try this again. Because you have a, if I do var rock, this, and we do char letter is, we can do even do opponent letter is A. Actually, you don't need to do it like this. I need to do it like this to specify it in line. I probably need to define it here as well. So do char opponent letter. It'll be okay. Why is it complaining? I must contain. Okay, never mind. Probably still need to do it like this, but okay. Our letter is X. Shit, X. Let's see. Win. It's annoying that you have to refer to it by letter. Good morning, done the first part, Python is faster, good music. Ah, thanks. Yeah, it's Harris Heller Stream Beats. It's I like that. It's royalty free and you can just use it without issue. So what's tripping me up is that I can't go back to refer to it like this. So that's just annoying. So I should probably first define these and then make a mapping with win. So I could do, can I do var here? No, it really wants me to just specify them outright. Okay. So we do char r letter, opponent letter, char r letter. So this will be the mapping. So I have rock, paper, scissors. We should probably also add a score and play score. Because this was 1, 2, 3. Okay. And now we should be able to do something like, let's see, we have, this will be horrible to read in a bit. I should probably turn this into a structure, but let me see. We have, because we have a mapping, right, to what it fights. So let's see. Let's see if I can do it here and change it later. Var x is, and then we want to do do you want to have a dictionary? Why is this tripping me up so much? It's only day 2. Because what I want to do is like rock.beats and then define what it beats and do it like that. So if we do play rock beats scissors loses paper. Right, and if it's the same, then it draws. So we do var mapping this. Right, so that's something that I want to do. And then there's a score for winning, drawing, etc. We have those in constants, that is fine. It's probably just a dictionary, right? Where you do a char and then a dictionary of char, comma, int for the points mapping. There's new var. And then we do rock dot. Let's see, we do it from their opponent letter. And then we do a new dictionary. And then we do paper dot r letter, comma, that is win points. Yeah, this is basically what I wanted to do. It just took me a bit to get there. Rock, let me see, paper. Paper, scissors. When we play scissors, we lose points, and when we also do rock, it's draw points. Okay. But basically, this is a mapping, an A/B mapping. I'm just thinking, in my head there's something that I can do to make this easier, but yeah, I'm not seeing it right now. Done that. Let's make the indenting readable, because there's basically 3 rules and just have to go by them, and I'm doing it in a not great way now, but yeah, let's just do it like this. Rock, paper, let me see, I need to code this out. Finish the second one too. I'll leave you to think. Now I have a meeting. Well structured the first part, surely will be faster the second. Yeah, thanks. But I always tend to overthink things and then get stuck. So I want to do it properly, and then the pressure of still knowing that there's a time limit. At least there's not really a time limit, but I want to not be slow. It's tripping me up a bit. I'll just leave it to this for now and then come back to it later, maybe when my mind is more at ease. Paper. So paper, this draws, because when it's equal, it draws. And that's what I meant. It's like there's always a forward mapping. There's always 3 states, like, and I thought that I could just reference to that, because when they're equal, because there should be like a function that says like bool win char A char B. So if A equals B, return null, and then you should check if there needs to be an offset between the two, and there's probably, but yeah, never mind, I'll just code it like this and it'll be good. So we have rock, we have paper. Paper is draw point. This is win, this becomes lose, and if it's scissors, paper becomes a lose, scissors is draw, and rock becomes a win. Okay, so this is the mapping that we have. Probably should have this in like a constructor. And do mapping is this. Okay. So we have that written out. We probably don't need this anymore. I probably also need to get it based on the character, so we have the dictionary char that returns this. R lookup like this. So we do rock.r letter. No, rock. I can't initialize this here. Let's see. So we do rock.rletter rock paper scissors okay, so now we have a way to find it easily, so we can what we can do now is, based on the opponent letter, see what our result would be in points. Probably, and we can get the place score from that as well. So let's see, for each var as did I do that right? Let's see. I don't even remember how I used that before. Let's see, there's no argument given to string second type. Okay, I'll revisit that later when I realize how my own extension that I wrote a few years ago works. because I have like this extension that I wrote. I probably can find it here. Let's see. Because I have this as extension. I need to get the 2022 version. Let me see, because I used it and it was exactly for this kind of thing actually. Ah, I should supply functions to do it, right? Let's see. Ah, okay. That's it. I can just give it to arrow functions and then it will give me the thing. So what I can do is dot as and do x, and this will give me a value tuple of two chars probably, right? Now I get a list of 2 chars. Okay, that is good, because I think I can do now list and then I do char opponent char mine, and I think this will map out. So now I can do for each var round in rounds. So now I have round, and then I have it mapped to the opponent and my character. So I can do var result is mapping round dot opponent round dot mine. So that will give me the score. So we do int score, and then int play score is, and this will be our lookup, and then round of mine. Let's see, R play, and then console, right line. We can do, and then so that will be rplay dot play score. This will be score. So this will be rplay dot. I never even added a label here actually. So I probably add a lookup to make sure that we can do rock versus scissors. For now, I'll just do the labels here. Round dot mine, round dot opponent. So if I just set a breakpoint here and make sure that we go to program and we execute day 2, let's see what happens. Boom, an item with the same key has already been added. Let's see what I did here. Rock, paper, scissors. Ah, let's see, this needs to be B, C, Z, and Y. I didn't even change the basic mapping. Okay, so now if we look at the console, it says X to C, which is, and now it's, yeah, I'll just make the mapping because it's annoying. I want to have readable so that we can process the logic as we expect it. String label. So let's add that to our config. So this will be label rock. Paper, and I probably wrote scissors wrong, right? Yes, I wrote that wrong, so let me correct that as well. Okay, so now for the lookup, you can just call that a lookup, and then we add, do label. So we have the full thing in there. What's wrong? Cannot convert place score string label to. It just needs to build again. I can do new, and now it should be happy. What's wrong? Char collection is invalid arguments. I don't know what would be wrong there. Should probably clean and rebuild because sometimes Visual Studio doesn't like it. See, now it's good. No, still not. I need to string label. Okay, now it should be good. Okay, thought I added it here as well, but let's make sure it's here as well. Now it should be everywhere. Everything happy now? Okay, good. And now we do the same, but we do opponent letter. And we have the same mapping. I should probably do this in code, but it works like this. So now what we can do is rplay and var their play is lookup opponent. And I should probably cache these outside. So I do int score. And do the same here. Like this, okay. Come on. Like that. So now we don't instantiate inside the loop, and now we can do their play.label, our play.label. And we can probably also add labels for wins, etc. But yeah, let's just run this, see if it makes more sense now. Scissors, we played rock, so we win 6 plus 1, so that seems good. Okay. And I should probably keep track of the score. So we do int total score, this is 0. And then we do like that. So I could probably do like a bit neater. That. Combined score, and this will be combined score. Like this. And then we do console.writeLine total score. Total score. So let's run this. There we have our output, and we should have scored 14,375. So let's see. What would be the total score if everything goes according to the strategy guide? Okay, let's submit that. Woohoo! Gold star! Glad it worked out in the end. Let's see what part 2 is. The elf finishes helping with the tent and sneaks back over to you. Anyway, the second column says how the round needs to end. X means you need to lose, Y means you need to end the round in a draw, and Z means you need to win. Good luck. Okay, that should be easy. The total score is still calculated in the same way, but now you need to figure out what the shape you choose. Okay, okay. But that should be easy, yes. But now we need to have a mapping for the inverse outcome as well. So yeah, let's see. We have part 2. So basically, we need to have this, and we need to have the value that we need to pick to lose. Okay, so what we can do is mapping point to dictionary key, and this becomes let's see, mapping where x value dot value to dictionary x key value dot values where right. Let me see. And then now I need the key of this, right? But that will just give me the value. Let me see. Because this mapping, it will give the play and then it will give all the values. We just want the values where that one has, yeah, that should be it. So mapping where x print value dot values where it's probably easier to just write out the inverse. Let me just do a dictionary car. Let me see. It's the same, except it's this one, except it does a chart for each mapping. It does the inverse of this one, so it tells you what you need, like outcome mapping. So now we can do for each. Come on, for each car key in mapping.keys. Now we do for each bar play in keys. Mapping key like this. And now we do create an inverse. We do this dot add key comma new this for outcome map this new this, and I think we can. Let me see. Yes. Now we do outcome map dot. Let's see. We have what they played. Then we need to go based off of the value. So we do for each car, we don't want the keys, we want the key value collection. So this should be a key value pair, yes. So let's see, what was the X was draw, const car, let's see, lose is X, const car, draw is Y, const car win is Z. Okay, so now what we need to do, if play dot value equals win points, and then we do outcome map dot add win, and then we do play dot key. So if we play this key, our outcome is a win, so we map the inverse. Else if play dot value, so this could be a switch actually. So we do switch base win points, break, lose points and draw. Hey mate, how are you doing? It's been a year. Let's see, here we do lose, and this becomes draw. We can actually do car map. We can do win. Map. Nicer map is lose. Map is draw. Default. Throw new not supported exception. Unsupported mapping. And this will be the play dot. Yeah. Let's see. Did my solution earlier. Yeah, I always do it after I bring the kids to school. So I'm just coding up part 2 now. So now we have an outcome map that should contain everything we need to do. So for part 2, let's see. And basically, we need to do an extra lookup here. So instead of round.mind, we need to do outcome mapping round.mind, and then it will give us the character that we need to do. Yeah, we need to have let's go back. First we need to do rplay, and rplay is based on like this, and then the score is based on rplay dot rletter. Let's see. This becomes outcome mapping, like this. So many levels. So this should be it. So let's just see if this works for the first time. Not my prettiest code. Yeah, I can imagine. I'm also messing about a bit. So let's see. The round is, it's C, and it says X, and X means I should probably do a lookup for that as well. X means lose. So they play C. Oh, we need to lose. C, rock, paper, scissors, so we play paper. So yeah, I think that works, right? Yes, score 0. As far as I can tell, this works. Oh, let's run it. So now this should be our score. Let's see if that's correct. What would the score be if everything goes against? So yeah, that would be this. Woohoo! It worked. Okay, so let's review what I built. I did a lot of stuff that might not be needed, but I like to code so that I don't code in the rules, but I code it with data so that we can have the code follow the data. And so if the shape of the data changes, we can have it do something else without having to change much of the logic. So I started defining all the rules of the game. So how much points you get for a lose, a draw, and a win. In part 2, we have a mapping that says this is what you need to achieve. So lose, draw, and win based on the keys. I have defined the rock, paper, scissors here with the letter the opponent uses, the letter that we use, how much points we get for playing it, and which label it should get to display. And then I made a few lookups. So basically to get based on either the opponent label or our label to get the record that we defined here. And then I made the mapping. That's basically the rules. So if an opponent plays something, what happens if we play those? So I coded those here. And I did an outcome mapping as well. So these are the lookups. I should probably just take the object and do our letter, their letter, and then add it. But yeah, I just coded it out for here now. Let's see. This was the outcome mapping that I just built for part 2. So this was needed to go from actually the score to see what we need to play. And yeah, basically this is the solution. I split the lines. I then use my as function to return a named value tuple. So rounds gets returned as a list of their play, my play. I could probably even have put in the lookups here so that we get a mapped list already, so that we don't have to do this part. Because basically I could do, if I change the code here, let me just comment it out. I can do a part A. Like if I do part A alternative, what I could have done was add this lookup here. Add the lookup to the mapping. And then the, let me see, the type mapping. And this is where I probably should have made, where I should have made classes for it so that we don't get this giant wall of definitions. But yeah, now we don't have to do our play and their play, because it's just round.opponent opponent letter our letter, and then we get round.mine.play score. So we get we save some part of it, not a lot, but this way it's already mapped. And this will be their opponent. So yeah, I could have done it like this and save 2 more lines and then get rid of this. But yeah, the definition here becomes so big. But yeah, I like the way I did it. It took me a while to get there, but yeah, it's just the way I like to code. Just set everything up in definition. Don't repeat myself too much. Yeah, so when we have to change part 2, we just need to figure out what our play was instead of what was passed in. So that we do that by using the outcome mapping. So we pass in what the opponent did and what we should do, and then we get what we should play. And the rest of the code basically stays the same. So I could have split this out into a function that returns it and then do it like that, but yeah, it's all okay. I had fun with this one. It took me a bit to get started, but it was fun. So yeah, more of a, it's not much of a challenge, but I spent more time on it, I think, than normally this early. Maybe I'm still just a bit rusty. But yeah, I just want to say thanks for stopping by. I hope you enjoyed it, and see you tomorrow.